bagong project. Ano na naman yan? Ito, bago. May 555 IC 4017 tsaka mga discrete components. Oh, yan. Testingin natin. Ayan, oh. 5 volts yung supply. Nagbabouncing back and forth yung ilaw. Yan ang tinatawag na Night Rider. Base sa nung unang TV sitcom na Night Rider, yung kutsing nagsasalita, yan yung kanyang ilaw. Yan na naman ang gamit niyan. Ay, panunuorin lang natin. Saka malalaman natin paano paggawa ng Night Rider using IC 555 at 4017. Di ba? We have now the schematic diagram of our project. The Night Rider using 555 and 4017 IC. For our project, we are using a 5 volt supply. And then we have this power LED. So that we know that the circuit is on. Blue LED is the color of power LED, a power indicator with a current limiter resistor of 5.6K. And then we have this 555 timer. In the circuit, what is the use of this 555 timer? What is the function? The configuration. In our circuit, we configure or design 555 timer as an stable multi-vibrator, or we call that sometimes called a pulse generator. Also, PWM generator, pulse width modulation. So this is an stable multivibrator or an oscillator that is generating a continuous train of pulses, or that serve as a clock pulse to the 4017 IC. So the purpose or the workings or the function of the 555 timer is an oscillator that generates a PWM into the output. When I said when we are going to draw the PWM, the train of pulses on and off, on and off, on off signal to the output that serve as a triggering pulse to the 4017 IC. It is due to the charging and then discharging. When the capacitor is charging through 5 volts, R1, R2, and then to the capacitor 1 microfarad 50 volts, it will produce a positive pulse or this pulse. And when it is discharging through trigger and to the threshold pin, the trigger pin, threshold pin, and then discharging also to the pin number 7, discharge pin, and then R1 from 5 volts, current flows into the pin number 7. During the discharging, it produces an off pulses. Then another, then continuing charging of capacitor, discharging, charging, discharging. So that's why we generated these pulses. Pin number 8 and 4 connected to the 5 volts. Pin number 8 is the supply. Pin number 4 reset in order not to reset the 555 timer. Pin number 3 is the output. Pin number 5 no connection. Pin number 1 ground. So this 555 will produce an oscillation or to serve as an oscillator or a generator or PWM generator or a clock pulse generator to the 4017. And then we now come to this IC 4017 IC. What is this IC? What is the function of the IC? This IC is called a decade counter, also known as the sequencer. When we are going to know or to use this IC, we are having a sequence, or this will serve as a sequencer. Or let us see the pin. Pin number 16 is the supply. Pin number 14 is the input. If pin number 3 is the output going to the input of this 4017 IC. So pin number 14 is the input, injecting a pulse to the pin number 14, which serve as an input of the IC 4017. Pin number 13, 14 to the ground, some sort of a reset and enable pin. And pin number 8, the ground. So these three are all grounded. The reset pin and the enable pin. Enable pin serve as in order to enable the IC, you need to put it to the ground. And also the reset pin, putting it to the ground to work properly. And then we have this output 3, 2, 4, 7, 10, 1, 5, 6, 9, 11, and pin number 12. Pin number 12 is used to cascade another IC. It is used to for cascading another 4017 IC. So, if this is a sequencer, there is a sequence. Once we inject a positive pulse, and this is a positive edge triggering pulse, as denoted by this arrow. If this is a negative triggering pulse, there should be a bubble. There's a bubble before the triangle. But here, it is only a triangle. When I say positive triggering, edge triggering pulse, positive, upward, or the positive edge, and then the negative, down. That is the negative triggering. Upon the positive triggering of the pulse, it will produce an output. Since we know that this is a sequencer, it has a sequence. Pin number 3 first is the one that will turn on the LED. And then pin number 2, pin number 3 becomes off. Number 2 on, and then it becomes off. And then 4 becomes on. 3, 2 off. And then 5 becomes on. 3, 2, 4 off. then 10, what is this? 7, not 5, 7, 10 on, then 3, 2, 4 off. So it continuously toggling the output. This is an output. So upon the arrival of this clock pulses, it will toggle the LED or the output. When this one is the first one receiving the first pulse, the current flows into the D1, which is the pass switching diode, turning on this LED, D11 red LED, and then connected all to the R3 470 ohms current limiting resistor. That is the first one to turn on. As I've said, this is an equal sequencer. The next pulse, it will toggle. This 3 now becomes off, and pin number 2 now is on, causing to, since this is D2, 1N4148 pass switching diode, it will flow the current to the D2 and then to the D12. This is now on, this is now off. So it continuously toggling the LED to turn on and off. And then pin number 4 now is on. It will turn on the D13. Why is it that there is a diode here? In order not to short the pin. Because we are going to make a night rider circuit. So this one is versus the on, 3, then 2, pin number 4 now, and pin number 7, okay, it will turn on, and then pin number 10, and then pin number 1, okay, and then since the LED is bouncing back and forth, the LED D15 should be the one to turn on. Since this is a sequencer, the sequence of the on of the circuit is, the next pin is pin number 5. It should be connected to the diode of the D9 so that it will turn on and then flows to the ground with the current limiting resistor. So we need to turn on this D4. So it should be connected to the next sequence, 6. It should be connected to the pin number 6. Then D14 will turn on. And so on and so forth. So it continues to turn on this one, then off. Then turn on this one, then off. Turn on this one, and then bouncing back and forth because of the sequence of the pin out, the sequence. This is a sequencer. Again, it will turn on this D11, 12, 13, 14, 15, 10, and then since the sequence from 5, 6, 9, 11, then 5, 6, 9, 11, and again to the pin number 3. So it there is an illusion of bouncing back and forth of the LED due to the, what is this of the diode? This is a current steering diode. So that when there's a current that flows to the D1, it continues to flow to the D11, then to the ground. Then pin number 2, D2, and then D12 to the ground. The current will not flow to the D3. Reverse bias. And then pin number 4, D4, then D13 to the ground. Pin number 7 to D6 to D14 to the ground. Pin number 10, then D8, D15 to the ground. Then again, pin number 1 to the D10 to the R3 to the ground. And then since it is bouncing back, we need to turn on this D15, and the sequence, since it continuously turning on the LED by the sequence of the number, pin number 5 to the D4 to the D15 to the ground, pin number 6, D7, D14 to the ground, pin number 9, D5, D13 to the ground, pin number 11, D3, D12 to the ground. Again, it will goes back to the, or it will go back to the pin number 3, continuously bouncing back the LED. That's why there is a current steering diode. We are using this current steering diode of pass switching, a pass switching diode, 1N, 4148. And all the LED, output LED, they are all red LED, 5mm in size. So, upon injecting the triggering pulse, for every pulse received by the pin number 14, it continuously toggling the LED. This one becomes on, off, 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 and then this one now becomes off. This one becomes on, and this one becomes off, 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 and continuously bouncing back the light of the LED.
po kayo yung siyang naunawaan po nga nila na kung punto ng batas ang pag-uusapan, pareho po silang walang karapatang magsabing angkinin yung sinasabi nilang teritoryo. Ngayon pa man ay kaunawa ko sa kanila na siguro po upang sila ay magkasundo na, ang pinakamahalaga rito ay yung pagkilala